Hi guys, in today's video we are going to talk about the complexity class p-poly, sparse language and polynomial devices. But before getting into the action, let's match our expectations. My videos depend on the wisdom of the crowd, a topic that really fascinates me. Since I'm studying this topic by myself, there might be an occasional mistake in what I say. Please correct me in the comment section below, if you wish to correct me of course. I promise to read all comments and we upload if necessary. Together we can answer tough questions in a better way. Also, please subscribe to my channel, I tend to upload many videos on this topic. To understand the notion of these terms, we will try to prove the complexity class p-poly equals to a made-up complexity class named after the biblical figure Achitophel, the counselor of King David. Let's jump right into it. Alrighty, p-poly. P-poly is a complexity class with problems which can be computed using polynomial advices of the length of the input x, using a deterministic polynomial Turing machine. Advice 3. An extra input that is depend on the length of the input x but not on the input itself. In other words, two inputs of the exact length must have the exact device, regardless of their content. A decision problem is in the complexity class P of some sort of a function that receives n if there is a polynomial time Turing machine with the following property. For any length of input, there is an advice string a of some length which is suitable for the particular length of the input, such that for any input of any length, the machine correctly decides the given problem on the given input, given an input and an advice a, sparse language. Notice that given a language that contains only strings of the length of n on a binary alphabet, there are exponential possibilities for words in that language, 2 to the power of n words to be precise, if no additional limitations apply of course, such that every second letter must be the letter 0, for example. A sparse language contains a polynomial number of words out of the exponential possibilities. For example, say that we have length equals 2, so as you can see we can construct 4 words out of it, so 0 0, 0 1, 1 0 and 1 1, which means some sort of exponential possibilities, because 2 to the power of 2 equals 4. The formal definition for sparse is the following: set S subset or equal of 0 1 star called sparse if there is a polynomial p, so for any n the size of the conjunction between the set S and 0 1 to the power of n is bounded polynomial Pn. So the size of S conjunction 0 1 with n appearances is lesser or equal to some sort of a polynomial Pn. Knowing these terms, we will try to prove the complexity class p-poly equals to the made-up complexity class p-poly Achitophel we mentioned at the introduction. So p-poly Achitophel. P-poly Achitophel defined in a similar fashion to p-poly except a minor change. The advices are good for almost all inputs. We would say that the problem S belongs to the complexity class p-poly Achitophel if there is a polynomial algorithm A, a polynomial P, and an infinity series of Achitophel advices, and a sparse that fulfill 1 for every n. The size of an is lesser or equal to Pn, which means an is bounded under some sort of polynomial. 2. For every input x which does not belong to the sparse, the input x belongs to problems S if and only if the algorithm A with the argument AX and input X returns 1. Notice that for input X belongs to the sparse, nothing is guaranteed. We would prove that both complexity classes p-poly and p-poly architophel are identical. To do so, we would assume that if S is in p-poly, then S is in p-poly architophel. Once completed, we would switch the rows. Assume that S belongs to p-poly architophel and see that it must, as a result, belong to p-poly. From these two directions, we would prove the complexity classes are equal. First direction. Assume that S belongs to p-poly. Then any length of input has a polynomial advice. The advice is good for any input, without further restrictions. Therefore, S also belongs to p-poly architophel. Therefore, p-poly is a subset or equal of p-poly architophel. Second direction. Assume that S is in p-poly architophel. We know that if the input is not in the sparse language, then the advice is good. Therefore, no modification is required. Our difficulty arises when the input X is in sparse. How can we promise that the advices receive guarantee a correct decision? Well, we would build a new advice the following way. We would look at the length of the input X and chain all words of the sparse that have the same length of the input. We would start with the words which are in S and proceed to the words which are not in S. Because the length of the input X is known, when referring to the new advice, we can determine when a new word began and when it ended. On the next stage, when we want to check if the input is in the language, we would compare the advice, which is the chain words, to the input. If the input is identical to the current word, we would look at the advice, then the word is in the language. Otherwise, we would move to the next word in the advice and repeat the comparison. If after all comparisons the input was found not to be identical to any part of the advice, we would perform one more step before returning that the input is not in the language. We would run the given algorithm of architophel on the original advice and on the input X. That final stage is because that if the input wasn't found on the previous step, then the input is clearly not in the sparse, but in regards to the question if the input is in S, we cannot know just by doing the previous step. In other words, for any input X, for any input X is not in S, if and only if the given algorithm of architophel that receives a new advice for the input and the input itself returns 1. We would notice that the algorithm always determines the answer correctly and complete its computation time in a polynomial time. That means that we had saw that given S is in p-poly architophel, S is also in p-poly, and therefore p-poly architophel is a subset or equal to p-poly. In conclusion, from both directions, we can determine that p-poly equals p-poly architophel. Well, that's about it. I hope you learned something new from this video, and please comment below with your thoughts. First degree studies in university are all about social studies, and this project comes to encourage that. Please subscribe to my channel. Until next time, good luck.